Hi guys, we're going to start a new unit today on a topic called similarity. And this is going to be a short one. We're going to get this done before Christmas break is over. So first and foremost, pause the video and start a new unit in OneNote called, I think we're on unit 5, similarity, or maybe we're 6, I'm not sure. But go ahead and start that new unit now. Okay, so back to the video here. First and foremost, we need to define some things in algebra. This should all be review here at the beginning before we actually get into similarity. We need to talk about ratio and proportion. Again, this should be review. So ratio is a comparison of two, real specific, two things. You can show a ratio in words as a fraction or using a colon. And really, we're going to focus right here in the fraction mode, but let me show you all three. So if you did, for instance, girls to boys, you can literally write out girls to boys like I just did in words. As a fraction, it could be girls to boys, in which case the fraction bar actually means the word to. So girls to boys is girls on top, boys on the bottom of that fraction. Or you can write girls to boys. And again, that colon literally means the word to. Okay, so three ways to show a ratio. A proportion then is two equal ratios. Okay, once again, you can do that in words, you can do it as a fraction, or you can do it with a colon. And once again, for geometry, we're going to stay in the fraction world, but I wanted to show you all three. So you could say girls to boy ratio is, I don't know, like 5 to 7. And you can literally write it out in words. As a fraction, girls to boys is 5 to 7. Okay, and with a colon, girls to boys, then you put 2 colons, is 5 to 7. That's a little weird, but that colon way is how you're going to see it on IQ tests and on other standardized tests. Again, we're going to stay more in the world of fractions for geometry. So we're going to show ratios and proportions in terms of fractions, which means you need to remember how to solve a proportion. Again, you had this in geometry class, in algebra last year, but let's do a quick review. So to solve a simple proportion like this example here, cross multiplying is the key. What I always do is draw a line down my equal sign so that I can see the difference between the left side of the equation and the right side of the equation, and I make sure that my equal sign stays on that line. So when you cross multiply, 5 times 30 is 150, and then 12 times x is 12x, and now you have just a simple one-step equation. Divide both sides by 12, and grab my calculator. 150 divided by 12 is 12.5. So keep your equal sign on that line. It'll help you keep things nice and organized. The problems can get a tiny bit more difficult if you've got the distributive property involved. So let's just have a quick reminder. Once again, I'm drawing my line, keeping my equal sign on the line, and I'm going to cross multiply. So I have 306 times 20, which is 6120, equals, and now I'm going to cross multiply again, but this time I need 24 times that whole thing, which means I need to distribute. So that would be 24 times x plus, grab my calculator, 24 times 50 is 1200. So now you have this nice little two-step equation that you can easily solve. So subtract 1200 from both sides. Once again, grab my calculator. 6120 minus 1200 is 4920. Divide both sides by 24. Oops, sorry about that. Divided by 24, and we have 205 as an answer. So these are the algebra skills that you're going to need to be successful in this unit. You're going to need to remember how to solve proportions, okay? Most of those proportions are going to come in the form of story problems or diagrams. So let's look at some story problems, because setting up a proportion from a story problem is super, 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 super important to set it up the right way. And there's more than one right way. So let's look at number 1 here. It says, in a photograph, Dan is 2.5 inches tall and his sister Emma is 1.5 inches tall. Dan's actual height is 70 inches. What's Emma's actual height? So the way I see it, there are 2 different types of variables going on here. There are people and there's height. And those are the 2 things that are kind of moving from thing to thing. You've got Dan and Emma, those are your people. And then you've got Dan's height and Emma's height. And so there's kind of 2 different things going on here. In addition to that, you also have the photograph. So you have real life and you have the photograph. So there's a lot to consider here. And when you set up your proportion, you need to consider all of that. So a proportion is 2 equal ratios, so 2 equal fractions. And I'm going to choose, and this is all a matter of choice. There's nothing magical about this. I could make a completely different choice, but I'm going to choose to set this up so that anything related to Dan is on the top of the fraction. Anything related to Emma is on the bottom of the fraction throughout the entire equation. And then I'm also going to make a choice and say that the first fraction is all about the photograph, and the second fraction is all about real life. Okay, so you've got to make those choices before you set up your proportion. Now it's just a matter of putting numbers where they belong. So Dan in the photograph is 2.5 inches tall. Emma in the photograph is 1.5 inches tall. Dan in real life is 70 inches tall. Emma in real life is, I don't know, so I'll call that X. I don't know what that is. That's what I'm looking for. And now I've set up an easy proportion. I can easily cross multiply this. So I've got 2.5. I'm going to just rewrite my proportion over here. Draw my line down my equal sign. Cross multiply. Grab my calculator here. So that would be 1.5 times 70, which is 105. Divide both sides by 2.5. Divided by 2.5, that's 42. And there you have it. Again, that's not the only correct way to set up this proportion, but the most important thing is that you make choices ahead of time. Where are you going to put Dan's information? Where are you going to put Emma's information? Where's the photo information go? Where's the real world information go? Make those choices ahead of time and then plugging in the numbers and solving is piece cake. Let's look at the second one. A car travels 106 miles and on 4 gallons of gas. How far can it go on a full tank of 12 gallons? So again, we need to make some choices here. I'm going to choose car on top, gas on the bottom. And so I've got 106 miles on 4 gallons. And so how far can it go is the question. That means I don't know how many miles it's going, but I do know that I've got 12 gallons. So making those choices about like, where are the miles going to go? Where are the gallons going to go? Make those choices ahead of time makes the proportion and the solving way easier to deal with. So I'm just going to quickly rewrite so I can draw my line down my equal sign, grab my calculator. 106 times 12 is 1272 equals 4x. Divide both sides by 4. Divided by 4, and that's 318. So that's 318 miles. That's how far that car can go on a full tank of gas. Okay, so now that we've got the preliminary work out of the way, now let's talk geometry. I'm going to skip this question about what does it mean when things are similar. We'll just get back to that in a little bit. Let's look at a geometric definition of similarity. So here's a small activity. If you choose, you can pause right now and you can follow these directions yourself and turn this into a self-guided activity. Totally do that. I'm going to go ahead and walk through it, but it's completely up to you whether you want to just watch or whether you want to pause and try it out yourself. Okay, so here we go. Draw a triangle called back with integer coordinates on the grid. That means I don't want something in the middle. I want something that's on a tick mark. I want integer coordinates. So I'm going to put B right here. I'll put, I don't know, A, I'll put the A right there, and I'll put C like right there. I don't know. This is completely random. All right, so there's my triangle BAC. Write the coordinates. Now I'm here at number 2. Coordinates of B, A, and C next to each point. So this point would be 1, 2. This one is 2, negative 1. And this one is negative 1, 1. Okay. Now multiply each coordinate of each point by the number 2. So let me rewrite my coordinates in here. B is negative 1, 1, and C is 2, negative 1. I'm going to multiply each of those by the number 2. So this would become 2, 4. This would become negative 2, 2. And this would become 4, negative 2. That number 2 that you multiplied by here, here, and here, that's called the scale factor for this particular problem and similarity. That's called the scale factor. Just a little FYI, a little vocab. Now it says, now draw triangle A prime, B prime, C prime on the same grid. By the way, that's what those little tick marks are called there. They're called primes. So you pronounce that A prime, B prime, and C prime. We're going to draw all of these points, A prime, B prime, and C prime, on the same grid. I think I'll change color for that just so we can see the difference between the two. So A prime is at 2, 4. 2, 1, 2, 3, 4. That's up here. So there's my A prime. B prime is at negative 2, 2. Negative 2, 2. That's here. There's my B prime. And C prime is at 4, negative 2. 1, 2, 3, 4, negative 2. So there's my C prime. Draw that triangle. There we have it. Okay, so the question then becomes, how do the corresponding sides of each triangle, we're over here now, how do the corresponding sides of each triangle compare in length? How do they compare in length? Well, if you multiplied each of them by 2, if the scale factor is 2, that means that the lengths of triangle A prime, B prime, C prime are double the lengths of triangle ABC. The important thing, though, is how do the angles compare? Well, if you notice, and I'm going to choose a different color here, like this side right here in green, B prime, A prime, and BA, those are parallel. Those are parallel to each other, which means that this angle and this angle are corresponding angles. And if you have parallel lines with corresponding angles, then those have to be congruent. Same here and here. Those are corresponding angles, and so they have to be congruent. And the same then will be true for angle C and angle C prime. Those have to be congruent. So it seems that the side lengths have doubled, but the angle measures, corresponding angles, are congruent. Angle A is congruent to angle A prime. Angle B is congruent to angle B prime. And angle C is congruent to angle C prime. And guys, these two ideas right here lead to the definition of similarity. So shapes are similar if their sides are proportional